Uh, can you all read what is there on the screen? Is it visible enough for that?
Yes, sir.
Okay, all right. Thank you. So this is sort of a dummy data set that I've created. And in this you should be able to see about, I think 11 or 12 features. And I want to know what are your, are you able to find any patterns, any findings from it? Have a look at this data set for a couple of minutes and let me know if there is anything in this that you find off in some sense, any patterns, so to say. So you don't have to think about the values themselves. So this has nothing to do with how things might be there in real life. So there might be a house with absolutely no amenities and a very high price. So just to give a brief as to what these features could be, the first one is just a serial number. The second one is to indicate age of the house. The third one is when the advertisement for the house was put up. The fourth one was the location of the house, then the count of bedrooms, the area of the house, the number of balconies, whether there is a kitchen present, whether there is a swimming pool present, how many bathrooms are there in the house, what is the price, and is it occupied. So this is roughly what it is. You don't have to think of it from how it would look like practically. You don't have to think about whether these make sense practically. But otherwise, are there any patterns, so to say? Okay, so if it's unclear, let me give a bit of context. So given a data set, let's start with that. Given a data set, what are the different steps that we would consider doing? So you are seeing a data set such as this. What are the steps that you would perform? Now your end goal is that you want to build a machine learning model. Anybody, any answers? What would be the first step? It could be anything. You can tell whatever comes to your mind.
I think cleaning the data.
Okay, cleaning the data, understanding the types of data present. Good. I like both answers. So firstly, let's,
Naming,
yeah. Yes, Krishna.
naming means
Sorry, could you repeat?
the namings,
What do
column
you, the column names?
label,
Okay.
label.
What do we do with the column names?
No, at least labeling of the column.
Okay, labeling, fine. So I'm going to assume that by any chance, are you going about saying understanding what this uh, data set, like what is our task? Do you mean in that way?
Yeah.
Okay, okay. So here I'm going to say that in this one, I want this last one to be, say, my label. And okay, there's another nice point whether we want to understand whether it's a classification or regression problem. Okay, let's go over a few of these first. So in this one, I want to do it as a classification problem. So this one I have whether this is just a binary classification, whether it's going to be 1 or 0. One of the other points that was brought up was type of data present. So in this, can you tell me what are the different data types that are there in this? Broadly, what are the different data types that we see?
It's a number, string,
Okay.
bi binary.
Okay. So good. So rather, numbers are what we call as numerical, and whatever we have as string, we call it categorical. So primarily, when we come to data types, we'll go with numerical and categorical for the most part. So there can be a few others, but largely for what we do, we can try and put them mostly in these categories, at least for this tabular data. Okay. And binary, what does binary mean?
Means like either it will be there will be two values only, so 0, 1.
Correct. So binary simply says that column will take only two values. So that can happen either for numerical or for categorical. Okay, so that does not restrict it. So in terms of data types, we are going to deal with numerical and categorical. Now, along with that, I think someone mentioned we'll do some data cleaning. So now with all this in mind, I want to know what are some of the things that we do as a part of data cleaning. And in that, can you also add if there are some things that we do specifically for numerical and specifically for categorical?
So first, for data cleaning, we can remove the redundant columns or rows,
Okay.
and for numerical, we can just amputate the null values based on their average.
Okay.
And for categorical data, we can just take the average and take which is repeating the most, I guess.
Okay. And this is for what to do what? So
Means
for
like
category.
if there is a null value or a blank,
Okay.
then we
For
can.
null values. Fine. Super. Okay. Anything else? Any other steps that we would do as a part of, say, pre-processing, data cleaning? Okay. All right. So in this particular one, let's maybe take a slight detour before we get to that. So I'm going to list a few topics, and I'd like to know which of those you are familiar with. Let's have this here. Okay, so can I get a show of hands as to how many of you all have not seen the week 2 lectures? Okay. Okay. All right. There's a good number of you. Fine. That's okay. I'm going to go on listing some topics, and we'll go from there. So first, see, seeing values, and along with that, let's add imputation. Then we have
So this step, whatever, hello?
yeah. So go ahead.
Yeah. Sir, so this step you are written, this is data pre-processing step.
Yeah, roughly, I'm bringing all the things that when you see the data, what are the initial parts that you do? So it could be either data cleaning, data pre-processing. We'll break down each of them. We'll put them in a proper category. But for now,
Okay.
I'm roughly sort of listing the different things you would have, seen in the week 2 lectures. Okay,
Okay.
so we'll get there. So here, is there anyone here who does not know what imputation means? Just a show of hands. We'll anyway be covering it briefly. I'd like to get an idea. Okay. Okay. All right. And okay, in that case, fine. Let's actually go ahead now. Yeah, that's fine. You can lower your hands. Now, yeah. So have a look at these columns. And are there any things that you find strange? Like, what are your thoughts? Now, firstly, I'm going to tell you this. You want to use a machine learning model. As one of you all has already mentioned, you're going to have to clean the data a lot. You're going to have to pre-process it. And these pre-processing things will include a few steps. So we'll discuss each of those steps. But first, we'll see the need for it. Now, I'm going to tell you firstly that one of the things is that your model largely requires that the data be numerical in nature. So can someone tell me what I can do for it? Firstly, in this data set that I'm showing in front of you, what are the columns that are categorical in nature, or rather not numerical? Let's go with that, which have string values.
Month,
Yes,
Attribute,
no,
location,
kitchen.
Location.
kitchen, swimming pool.
kitchen, swimming pool, bath. Yeah.
Occupancy, sir.
Okay,
Location
so
also.
okay, so far I've heard add month, location, kitchen, swimming pool, and occupancy. All right. So primarily, I was looking for columns that are having string sort of this in them, ones that are not numerical, so to say. And in that, the first four will come, right? As Rishad also has mentioned in chat. So we have these four columns in add month, location, kitchen, and swimming pool. So we need a way to convert them. So can you all think of what would be a good way, like, or anyway, can you come up with some idea with which I can convert this
Yes,
text to number?
you use a dictionary for a cut like January, February to give a number,
Okay.
and
So
area location for also.
okay. So you're suggesting that I use a dictionary-like setup where I'm going to map the values of the column
Yes, sir. To a
add
integer
month
value.
and location to an integer value and replace them. Good. Okay. Uh, what would the values looks like? What would the values look like? What could be one mapping? Give me your first few examples for add month.
Sir, 0 to January or 1 to January, and then
Okay.
also increment that, sir.
Okay. So in that case, I'll just add a column to the left. So let's say add month as number. I put add month in. So according to the way Vivek wants me to encode things, I'm going to write 1 here, and I'm going to write 2 here, 2 here. October would be 10, I
10.
think. Okay. What is August?
8,
8.
sir.
8. Okay. To November is 11.
11. 3.
Okay.
11. 3.
Okay.
5. 6. 6. Yes, sir. 7. 7. 10.
Okay. What else do we have?
10. 12. 12. 1. 3. 9. I think 9. Yes, 9. 9.
Okay. Fine. So is there anybody who did not understand what we did with this? Okay, so what we've done basically is we had these text values and now we have found a way to convert them to a number. So what we have done is we have mapped January to one value all the way until December to another value. So now that this is a number, can anybody think of like, will there be, what are the advantages to it? What are the disadvantages to it? Can you think of anything along that lines? Anybody, any idea about that?
Can you
I
repeat
think
it?
I think in terms of advantage, we get the data in numerical. So whatever like algo, machine learning algo work on that data.
Okay, perfect. So previously we had the issue that the text data could not be processed. Now we have a way to convert the text data to a number. That way we have a way to process this data. Perfect. Can anybody think of what could be an issue with this?
To know the add month, we have to again visit the dictionary and get the month, because add month number will not give the month. We have to revisit the dictionary and find the keys for that.
Okay, so here the point is that on some level we have lost what the original data is. Okay, but at least with this current form, it is recoverable in some way. So that is something I can say. So maybe if I had the dictionary mapping, I'll get back the month. But I get your point. The moment someone sees these numbers, they may or may not really know unless they know the mapping.
Yes, sir.
Okay, all right. So
We
are there
cannot
any
have
other issues?
numerical operations in it. Still, it is a categorical.
Okay, good. So I might perform numerical operations on this, but at the end of the day, it's a categorical thing. Okay, anything else? Can you think of any other issues? It's somewhat along the same lines.
If you do numerical operations, after doing the numerical operation, we don't know which month to give to the add month. Suppose you do 10 plus 12, it is 22. So 22
Okay,
is not a valid number for any month.
okay.
We have to
So
convert that to month.
right. So instead of that, what I would say is, now as an example, I'll just show it to you. So there is something called as scaling, which we'll be learning. I will say instead of just adding plus 10, again I know some way, but here I might even say that whatever is there as 1 to 12, I am now going to write it in decimal format. I don't know if this works. Let's see. Yeah. So now I'm like encoding this in further in sort of more another different way, so to say. Okay, this is not converting it to a decimal, but you get the idea. So if I were to actually get those values, I'm going to have everything as 0.0 something all the way until 12 will end up being 1. Okay, so let's see if, yeah, so this way I have my values. So 1 was 0.083, 10 is 0.833. Now, can you all agree that this column makes absolutely no sense to me? If I show this to be the month for someone, this at least I can say it's in some way it's discrete, so okay. But here if I see this, there is no way I could think of this as the month. Okay, so that is one more sort of problem, so to say. Anything else? Any other problems can you all think of if I do it this way? Okay, all right. So that is there. So now, since I have, okay, let's look at this column bedrooms. Can you say that this house 1 has more bedrooms than it has than house 5? That is fine, right? So house 1 has 3 bedrooms, house 5 has just 1 bedroom. Now for this house, if I look at the add month, it says 1 for house 1 and 12 for house 5. But does this make any sense? Can I say that this particular, the add month for house 5 is greater than add 1, house 1?
No, sir.
No, right? So what has ended up happening with our mapping setup?
We cannot do the comparison.
Yeah, so we have brought about some sort of setup where we are ending up saying that this particular month, December, is higher than the month January. So we have brought in some sort of comparison. Is this part clear?
Yes.
Anybody any doubts with this?
No.
Okay, all right, perfect. So in that case, do you think there is some other method we could come up with? Can you think of any other method in which I could have converted this January, February, October to numbers? Okay, all right. So in that case, I'll discuss the next one. So here, let's do it for this area 1, 2, 3 that is there. So what I'm going to do is, we have, how many unique values do we have here?
4.
Okay, we have 4 unique values. That's right. So what I'm going to end up doing is, I'm going to add 4 columns. Okay. So what I'm going to call this as location 1, location 2, location 3. Okay. So does this give you an idea? So what can I do? Now that I've shown the addition of 4 new columns, can you think of some way in which I can convert this one to numbers?
1 0 0 0.
Okay. So I think a couple of you have said that. I can even see it in the chat. So what everyone here is suggesting is that we convert this to new columns such that whenever it is present, whenever this area 1 is present, then this column will take the value 1. If not, it will take 0. Okay. Does this make sense?
Yes, sir.
Let me actually try this.
True values.
Okay, so basically, of course, if you learn this tool, it's good that you'll have learned an extra tool. But anyway, I just did this to get this done with quickly. So I've done the same for location 2. Let me actually do it for the others as well.
So why we did like that? We, could also do in another way. Instead of writing ones and zeros, we could write 1, 2, 3.
Sorry?
So instead of writing ones and zeros only, we could give other numbers as well, 1, 2, 3, 4, and just write in one column.
Yeah, so that we just discussed the problem with this one, right? So when I had the month, the moment I did 1 and 12 in one column itself, then it ended up saying that December that is there. So the add month for this house 5 was greater than this one. I could say something like that.
Okay. To resolve that issue, we did like this.
Yeah, so now we have sort of overcome that issue, right? So here, let me take this. I'll just finish this up and then we'll continue.
So you need to fix the column, reference column.
Yeah.
Dollar before E.
That is fine. It's not necessary. So I mean, I can, if I want to do it in one swipe, then I can do that. But anyway, since it's 4 columns, I just decided to do this. Okay, so that way our 4 columns are now filled. So what do you notice from this? So if now area 1 is present, amongst these 4 columns, only one of them will have the value 1. Is that right? The rest of them will have 0. Same way, if it is area 2, only location 2 is 1, the other 2 are 0. This is okay. Is this clear to everybody? So now with this, have we converted it somehow? Can you all accept that whatever I had as text previously has now been converted to some numerical format? All right. Okay, good. So with this, can someone tell me the name for this first one? This is what we call this process of converting these categorical columns to something numerical. What is it called firstly? Conversion of categorical to numerical. So when I'm writing these strings as numbers, yeah?
Feature encoding.
Okay, perfect. It's called feature encoding. Specifically, can you tell me what this one was, the first one? Does anyone know what this method? Sorry?
Binarizer.
Okay, so this is not binarizer. This is a different kind of encoding. It takes this one. I'm talking about add month. Anybody, any answers? What do you know? What kind of encoding this might be?
Encoders.
Yeah, so these are all encoders. This process is called encoding. This first one that we did for add month, it is actually called as ordinal encoding. Okay. So we'll see that in detail. So here specifically, I don't know if I had mentioned it. Yeah, so this is the ordinal encoding that I had mentioned. So what ordinal encoding does is that it converts whatever this text is there to some numbers, but it does it in one column itself. But the problem is that it brings in an implicit sense of ordering. Okay. So whatever is there now, previously I had January, February, and so on months, but now they have become ordered numbers. So there is an implicit sense of ordering that is brought. Can you, whatever, it doesn't have to be this data set. Can you think of some example where that might be useful? So the moment you see a column with some kind of text, I want to use ordinal encoding there. Can you tell me where it might be very useful?
So grading.
Okay. Geeta, I think your voice is breaking. Okay, when we prefer some products over the others. Okay, Geeta, can you repeat? Your voice was...
Yeah, like if there's a temperature comparison of...
Okay, I could again hear you briefly, but I think you
that
said something
numerical.
like temperature
like
comparison.
hot, cold,
okay, perfect. So
temperature.
Yeah, right.
Yeah, some.
Okay, so basically anything that is on a scale, so to say. So if the categories themselves also have sort of a comparison, wherein I could say low, medium, high, or maybe bad, neutral, good. That way, the moment I do ordinal encoding, the feature already had some sort of implicit ordering to it, but the way I'm converting it, that is also capturing this particular sort of nature that is there in the feature. So is that idea okay? So whenever we have a column, just categorical in nature, and especially so that it has an ordering, we can definitely go for ordinal encoding. Now, can somebody tell me what the name of this particular style of encoding is? What we did here of breaking one column to 4 more. The list was there in the other tab. Does anyone know what this is called? Okay, one hot encoding. Any reason as to why this is called one hot encoding? Okay, any answers?
Only one
Because of
Only one is
only one value can be one at a particular time, right? The others
Perfect. Yeah, so both your answers are right. So it is at any given column, it is just one is hot and the rest are cold. That is what it kind of means in the sense in any given row. Now here, if I look at this first row, amongst these 4 columns, only one of them is hot and the rest of them are all 0. So that way this is one hot encoding. And you can also agree that now I don't have the problem of comparison, so to say, or at least not as badly as it is there in the add month case. But do you all see any sort of issue with this method? Can you think of any? Yeah, so anyway, I've mentioned the pros, but if anybody would like to say one pro and one con for this, that would be good. Can you think of one positive and negative to this method?
We are adding more features.
Perfect, absolutely. So we are adding more features. What I had as one feature previously has now become 4 features. Perfect, Shamir Rishad. So if I were to do it for a month, that would have been my next question now. I did tell you that there is a problem that if I were to, do it, if I were to encode it like this, I'm going to have, implicit ordering if I do ordinal encoding. But if I were to do one hot encoding for this, I'm going to end up getting 12 columns. So that is also problematic to me, right? So now coming to that, so what really is my best method, so to say? We'll get to that, but let me move this to a new sheet. Okay, all right. So what I was saying is we have these 2 methods. Both of them have their pros and cons. But the thing with these methods is that we can't always say for sure that one works best or the other works best. So the ideal way we are going to go about things is that we are going to be trying out different methods, different combination of methods, and whatever works best, we are going to end up retaining that method. So encoding your categorical data to numerical is one part of the entire machine learning pipeline, so to say. But it is important that you understand the distinction. That way you can choose your sort of method wisely. Now, can you tell me what would be a good encoding method for these 2 now? So we have 2 more remaining from the initial list. So how would you all go about doing this?
One hot.
0 and 1.
Okay. So as a matter of fact, so here I would personally say, you could go with either of them. So for one, if you use one hot encoding, it will only become 2 columns. But if you were to use ordinal encoding also, it would be just 0 or 1. And to say whether, having no kitchen versus one kitchen, it's probably okay to even make that comparison. Now, one of the other fields where it would have gotten interesting is okay, can you think of one case where, it would have been helpful? I'm talking about a binary sort of feature wherein one hot encoding might have been better. So think of a binary feature which does not have an implicit ordering. It's probably a bit hard to answer it this way, but some of the common data sets, if you work on data set that involves people, one of the common features that you'll have is gender. You're simply going to have something like this. Yeah. So it can simply keep going as something like this. And in this case, putting 0 or 1 or 1 or 0 might not really make sense to compare it directly. So that way what you can do is you can make use of one-hot encoding. So it is going to give you 2 columns, one for each gender, so to say. Okay. So with that, we roughly know briefly about now converting text or categorical columns into numbers. Now looking at this particular data set, we've been looking at this for some time now.
If we
Is
are
there any-
going for binary, sorry to interrupt, if we are going for binary only, is it necessary to have 2 columns instead of one only?
Yeah,
Because
I'll get.
if we are assigning 1 to male and 0 to female, then it's already sorted.
Yeah, that is fine. So that's what I said, right? So if we were to put 1 and 0 in the same column, we come back to the idea that, putting in numbers in the same one for male and female, yes. Like I said, for this binary column, it absolutely works fine. Now you can put it in the same one, even if I were to do one-hot encoding or if I were to do ordinal encoding, it would end up being of a similar setup. So if I do, in case people, let me briefly put it here. I'm going to put gender male, gender female roughly. Say it was originally, it was something like this. Okay. And if I were to do ordinal encoding, maybe it took something like this. But if I were to do one-hot encoding, it would be something like this. Okay, so here the point is that why do we even, do we actually need to have 2 columns? But then if you look at it here, if you see after I do one-hot encoding, the column that I get here is actually the exact same as the column here. So these are some pros and cons that you're going to end up weighing. So this actually brings in another point which I thought of discussing later. When you do one-hot encoding, you don't always need to make columns for everything. So as in if I have just 2 categories, if I do it for one category, it is understood. If it is 0, it means that it was present in the other column. So that information is already captured by this guy. So that was one of the parts. So
this is applicable only for binary, right?
So that's the thing. It's not just for binary. It's somewhat you can extend this idea to multi-class setup as well. Now for one, especially when I said why you might want to use one-hot encoding, when it is just 2 categories, you can, as Nishan mentioned, maybe you can just do it with 1 column. But if you have more than 2 columns, then it is, if it's maybe just 3 or 4, then it might still be okay to use one-hot encoding because it doesn't really blow up your feature space so much. But if I had something like, let me replace this with ABCs. Okay, let me just put it as 1 second. It's buggy. Okay. So if I were to have this, now here what I was trying to say is that if I want to do one-hot encoding to this, then I don't have to, let me call this as group A and group B. So now if it is A, I'm going to put 1, otherwise it's going to be 0. Okay. So what should the value here be? It should be 0, 1, 0, 1, 1, 0. This is okay. Is there anybody who did not understand what I've done here? This is my original column. And I have done one-hot encoding to this. But instead of doing it for all 3 columns, now I've done just for GA and GB. Can someone tell me how I will identify when C comes?
Yes, sir.
Both are 0, then C.
All zeros, yeah. Both zeros.
Perfect. So the moment, so it's more of what, rather than considering just the cases where these guys have the value 1, we are also looking closer at the values where they have 0 as well. So if both these columns now end up having 0, it automatically implies that the third category is what occurred at that point. So what advantage that did this give us? It allowed us to reduce our feature space by one column. So now this will sort of build up. So if I'm going to use one hot encoding on a lot of columns, I can now do away with one column for each such feature that I've converted. Okay. So is this idea okay to everybody? So when I'm using one hot encoding, I don't have to break it into all the unique column values that it takes as multiple columns, but I can choose to remove one of them because that information is captured by the others.
So you can remove only one column, right? You can.
Yeah, you'll only be able to remove one.
Yes.
Okay. So that was one thing, and with that we can also think of it gives us two more important ideas. One is that if one column already captures the entire information, it captures some X amount of information, and if another column also gives you the same information, then you don't need both of them. Now here basically if I take the gender, female and male case, or even this one for that matter, so the moment these two columns, they take these values 1 and 0, I don't have a necessity for a third column, because whatever the third column will tell me, it is already being told by these two guys. And is there any numerical way in which I will, I can get some idea about this, let's take the case of simply gender. Now, when the value for one column, if I do one hot encoding, so if this is say 1, 1, I'm just putting some random numbers here. Now, how do I know whether I should, if I give you two columns like this, how do I know if they both are capturing sort of like the same information or same amount of information? Is there any numerical way in which I can find that out?
The sum should be 1.
Okay, if I take the row sum, it should be 1 is one thing. Okay, but I'm saying if I look at the two columns, how do I know if they are more or less giving me the same kind of information? Is there
Total of all
one
the
should
ones
be blank.
equal to number of queries.
One should be blank and the
Alright,
other
so
should be occupied.
okay, that is one thing. But I'm asking, is there some numerical quantity, some statistical measure that tells me that these are more or...
Sum of both the columns should be equal to number of rows.
Okay, I was okay. That's fine. I was not necessarily looking for that. I'll tell what I was looking for later. So it's actually present in the other columns also. We'll have a look at this first. So here we've been seeing this data for some time again. So can you all identify some sort of anomalies or whatever that is present in this? So we just spoke about redundant columns. Can you spot something like that? Anybody, any answers?
Bedrooms, sir. Bedrooms.
Okay, what is the issue with bedrooms?
Multiple columns for the same feature.
Where are
Bedrooms and bathrooms. Bedrooms and
Yeah.
bathrooms seem to be the same.
Right.
Oh,
so
yeah. Yes.
yeah. So the catch is that here I ended up giving both of them. They are the same ones. It's the values that both of them take are the same. So that means one of them is highly redundant. So now let me actually see if this works. So I would have to. You all see this? So do you know what function I used?
Correlation coefficient.
Yeah, so what I calculated was the correlation. Now, specifically in this one, because I artificially generated this, I made sure I copied both of them to be the same values for different features. But what ended up happening is that if you have a very high correlation between features, they might more or less be capturing the same information. So that is what was happening even with the case of that one hot encoding example that I showed. If I have two columns, one for saying, just male and another for saying female, they're both going to end up having a very high correlation. Let's try this out. It's either a very high positive or negative correlation.
This will be negative correlation, right?
Right. So that's what I was getting. The correlation will be high. Positive or negative is either of them will say that they are capturing
It
similar
will be negative
information,
one.
so to say.
Yes.
So now if I were to do, you all recollect this, right? This is how the data would look like if I were to do one hot encoding. If it had two columns, then it would look like this. But if I calculate the correlation, it's a very high value. So correlation goes between +1 to -1. Having very high correlation, either positive or negative, simply says that your features are more or less, trying to communicate the same kind of information, or whatever one feature is contributing will be communicated by the other as well. Okay, so that way we can again do away with one column. So what are the, can you sort of reiterate whatever are a couple of ideas with which we can reduce columns? We discussed two so far.
If two columns are correlated, then only one is required.
Okay.
Are positively or negatively correlated, highly correlated, then you require only one column.
Right. Anything
Two or
else?
more columns, right?
Okay. So the other one is kind of related. It's just that even with one hot encoding, even if we have many categories, we can always drop one of them. We will not always need it. Okay. So far I'll just.
So can we do price by area? That is the unit of, the price of unit of area.
Okay, you want to create a new feature. Is that what you're saying?
Yeah. Instead of two features like area and price, can we have one feature that will?
That's another very good idea. So for who was it who just answered? I was not checking.
Answer.
Okay, Satya, right? Okay, all right. So what Satya was suggesting is that we have two features here. Can we, combine them and just have a feature called as price by area, and use that instead? So that is also definitely a valid idea. And when we work with data sets, often, like I said, for most of the things, we will not know for sure that this is the best method. So the idea is that I'm going to keep trying different methods and come to it.
But so, price by area will be different for different areas, right? It will be, so we will still require two columns, right?
Yes, sir.
Sorry?
No, that will represent the unit square feet price. So
but to know the price, you still need to know the area of the house, or you need to know the price. You should have the price to get the area of the house. So still we will require two columns only, na?
Okay.
Either area or price along with the area by price.
Okay, before we get to it, I'll just finish this discussion. So for one, here our target variable is occupancy. Okay, so that is one column that we can't really do much about. Now what Satya suggested is that we are going to create a new column called price by area. We are going to use these two columns to calculate it. I'm going to take this value, divide it by this value. Whatever value comes, I'm going to create it as new column called price by area, and maybe I'll write it as rupees per square feet or something. And then I can choose to delete these two columns. Okay, I'm going to delete column K and column F, and I'm going to say that the information by both of those guys is captured by this new feature called price by area. Okay, so that was sort of the suggestion given by Satya. So what I'm saying is that in general, when we try things out in practice, we can definitely create a new column called price by area. So if it makes sense, we can definitely do it. So in a lot of the data sets that we have, we make use of domain knowledge quite a bit. So we try and think and see if this makes sense. If the feature called as price by area, we think about it, we see if it makes sense. If so, we create a new feature. But then do we keep or delete the original columns is a different question. So we can again check the correlation, we can see how it is, and then we can take a call. So in practice, we might have to keep trying different things, and the end result will be only dependent on the final performance of my model. So all these things, they are done very iteratively. I try some method, I see the score, then I come back. But creating a new feature is definitely a valid idea. Creating new features is one of the important steps that we learn, but it's not always going to be very easy to do it. Okay, now do we have any questions?
So for correlation, what is the limit till which we can keep the, for example, what is the maximum correlation
value, right?
coefficient?
So usually we want our features to be as uncorrelated as possible. Okay, so when do we say two features will have, what is the value for which features will have, will be maximally uncorrelated or will have no correlation?
Less than 0.5?
0.
0.
Less than 0.5?
Okay, so I was asking for maximally, them being, or rather them being uncorrelated, the value is 0. If you have a value of 0, it simply says the two features are not correlated. And that is a good case for us. That means the information that one column is providing to us is not being provided by the other column. Now, at the end of the day,
in practice, the correlation coefficient can be anywhere between 0 and 1,
yes,
right?
it will be between -1 to 1. We'll come to all that. So, firstly, you've done MLT. So, while doing MLT, we've learned about training these different algorithms and building these models, and we are going to be getting these weights. Now, if you take something like a linear regression model, what does it do? It finds these weights, and those weights are nothing but you can think of them in some sense as the importance we give to different features. Is that right? So if this is a little confusing now, it's fine. Whenever later when we come to linear regression, we'll again discuss it. So with models like linear regression and a few other models, we'll easily get something called the weights that we get can directly be thought of as the importance of the specific features. Now, in this case also, if we have two features that are highly correlated, of say a correlation of 1, then I can assign my entire weight to one column and give 0 to the other because I'm getting no information from that guy. So now if I have uncorrelated features, that means my model will give good enough importance to both of them. Okay. Now coming back to the question at hand, 0 is for the columns to have no correlation at all. But in practice, we can have values anywhere between -1 to 1. And high correlation, it is going to depend from application to application, from data set to data set. So later on, we are going to plot something called as the correlation heat map. So it is, first we get the correlation matrix and then we can print the heat map for it. And that will show you the correlation of all features with everything else. And depending on that, we can, consider dropping one of them. Okay, there was actually one more type of column that I wanted to add. So let me briefly add that column also.
So when do we get a -1 correlation coefficient?
Did we see a -1 correlation today in any of the exercises that we did?
Yeah, you showed one.
Male, female only, no?
Yeah, can you describe what happened there?
If it is male, it can't be female, so that's highly negatively correlated.
Yeah, so
either of them can be dropped out.
Right. So firstly, what is negative correlation? Negative correlation simply means when, say, one feature increases, the other one keeps decreasing. Right.
Okay.
So or the
one
other
is
way
the
around.
opposite of the other.
Yeah, basically when whatever direction one feature moves, the other one moves in the opposite direction.
Okay, thank you, sir.
So in those cases, the features can be having a high negative correlation. Okay. So I've added one more column. Okay, we so far we've seen how many of them? We've seen add month, bedrooms, bathrooms. We've discussed it a bit. Now, any other columns that you all find interesting? Anything else? Can you spot any other relationships?
Do we need
Garden has everything 0.
All are 0, yeah.
Okay, so let me scroll all the way till bottom. Okay, we just have 3 1s at the end.
Yeah.
So at the end, of course, this has been a late addition to this particular data set. But here, again, what I wanted to convey is even these columns, many times you are going to find data sets which have columns where all of them take more or less the same value. So in that case also, these columns don't offer
That
much
goes for
information.
kitchen also then.
Kitchen is,
That
yes.
holds true for Kitchen also then.
Yeah, kitchen is
Very
mostly,
less of them are no.
Yeah, but in this case, at least we have 3, 4, 5, 6, 7, I think roughly 8 or 9 values. So 9 values out of 25, roughly close to 30% is one value, whereas the other is the
Swimming
having
pool.
kitchen.
Swimming pool is very few are having, yes.
Okay, swimming pool we have again two, yeah, maybe just 3 values. So that also has a fairly, what is, there is one particular terminology we can associate with these columns. They have a
Sparse.
very low dash.
Sparsity.
Okay, the values are sparse, that is true. But is there anything else? So instead of zeros, maybe I had all of these as ones and just these 3 guys as zeros. That time, can you say something about it? And in fact, it doesn't even have to be
Variance,
binary or
low
discrete.
variance.
Yeah,
Very
variance.
low variance.
So these are columns with very low variance, and columns with low variance usually tend to also have little information. So if we want to reduce our feature space, we can also choose to eliminate columns with low variance. Okay, so that was one thing I wanted to convey. Anything else you all can spot in this particular data?
Just an observation in terms of the current sheet. If it is a garden, then the rate is also high. If has the garden and swimming pool, then the rate goes higher. Does that also not mean that it is highly dependent? I mean, those variables are highly impacting the price.
Okay, so coming to the general idea that you've communicated, it is true that if features are dependent, that is something that we want to capture. So as in the dependence of, say, here my target variable is anyway occupancy, but if the interaction of features, like for example, garden plus swimming pool is contributing to something, definitely that is something I want to capture. And for that, we can make use of something called as feature interactions as well. Or simply put, we can even try and create new features. So wherein I am custom generating a feature based on, say, my domain knowledge or observation, saying that if a plot does not have both garden and a swimming pool, I'm going to give it some value X. Otherwise, I'm going to give it some value Y. So these might have a very high correlation with my price or something else. So that again comes in a part of feature engineering, and with time you have to learn this. You'll come up with these methods on your own. Firstly, is there anybody who did not get what was just suggested? Okay. So roughly what I was saying is, if the combination of two features are also impacting my target variable, then I can choose to make something out of it. Like I can try and create a new feature out of it. Okay. But to this data specifically, that was the first point that I kind of brought about, that, in terms of practical setup, these things have no value. I've just randomly put in some of these values. Okay, so here, yeah, that the dependency, if it's present, it's a good catch, but these numbers were randomly generated.
So for the month, we'll have to keep at least 11 columns, right? At least, if not 12, then 11 columns.
Yeah, if I'm doing one hot encoding, I have to keep 11, but we discussed that the problem is my feature space will blow up. But if I were to use ordinal encoding, it brings about an artificial sort of ordering. So that is a positive, negative sort of, we'll have to try out both the things, and it's a trade-off, so to speak. Okay, let's
same line of thought. Sorry to interrupt. In the same line of thought, if two features are having high correlation, negative or positive, then one of them can be dropped off, was our point of discussion.
Correct.
But in terms of multiple, like in terms of one hot encoding for 3 or more columns, where we are dropping out only one column, how is its correlation measured against the sum of all the other columns of the one hot encoding?
Okay, so here we are roughly going to look here. The correlation, if you look at each of those columns individually, it is going to be a bit different. So we might not necessarily have a very high correlation. But overall, in combination, those 3 columns are capturing the same amount of information. So we kind of have to go in that direction. So we can't specifically say, okay, now that I've broken it into all columns, I'm going to expect a very high correlation for sure. That will not end up happening. But combined, because the model doesn't need to individually look at things, right? It doesn't need to look at one column at a time. It is going to be able to process the information that is present in all of them, and it will collectively be able to identify that, okay, whatever these 4 columns are communicating, it can be communicated with just these 3 as well. So that is possible. That is one thing. So here we will have some sort of overlap with the ideas of PCA as well, where we have a couple of directions and we try and find a new direction which captures maximal variance. So okay, so that is kind of how we can go about it.
So there should be a correlation between age and price, maybe the location also. The property age.
Yeah. So that's what. So in a practical data set, we might have all those things.
Yes.
So here I'll say that for the price does not. I'm not looking for correlation with price. These are all sort of like dummy data that I've just generated to see the different methods that are that can be used and so on.
Yes, sir.
Okay, so there's a couple more things to discuss with this data set. Can you all spot anything else with this data set? It's a bit involved. Maybe I'll give a hint. So it has to do with the columns balcony and swimming pool.
If there is a swimming pool, then there is no balcony.
Yeah, so that was just one more sort of subtle thing that was added. So once again, that goes to say that I don't just need to have ones and zeros. I might sometimes even have it as a yes or no thing here and numbers here. And it's anything that is greater than 0 will not have a swimming pool, and otherwise it has a pool was something that was there. So this information also is perhaps entirely captured by this column. So I might not really have much need for this. So in this case, I might not always have a very high correlation, but the information is perhaps captured. So if you are in a situation where you need to cut down on some features, this could also be one way to look at things. So broadly saying, we've so far seen that we need to do some encoding to convert these categorical columns, and we saw some manual methods with which we might want to reduce these columns. Wherever there is high correlation, wherever there is low variance, that is most of the column is just saying the same thing, so we can even choose to drop those. Now let's see one more sort of part with this data set. Now let's just consider this first 5 rows. Now with these 5 rows, I want to know which of the houses are closer to each other. So I have houses 1, 2, 3, 4, 5. I want to go about finding out which of the houses are most similar to each other. So can you all tell me what I can do for this? How would I go about this? You don't need to calculate or give me any values or something.
First check the area. We should check the area, then the room number.
Okay.
Closest in what context?
Basically, someone came and told you, okay, this is the data that I have. You tell me which of these houses are very similar to each other. So how would you go about it? Okay, so what do we mean by a vector map? Like, what do we want to map exactly? We can get them as vectors, but what then? What after that? How do I measure if they are similar?
Norm.
Sorry?
Norm of the difference.
Okay, so sort of like calculating distance, right?
Yes.
Okay, so for that, we'll have to do one step, which is to convert it into numbers. Say for this one, I've converted it using some one-hot encoding, ordinal encoding for this guy, and for this guy also we'll do that. This one also I'll represent it in numbers. Okay, so I've done this. Now I can calculate my distance. That's fine, right? So can someone tell me what the problem could be if I were to calculate the distance? Can you see any problem firstly?
Yeah, that age, the add month could be a problem, right? Because
serial number is the problem in this first.
They are not in a perfect scale. So
Sorry, your voice is breaking.
it is not in the perfect scale. Scale is not there in area. And
Perfect. That is what I was looking for. So that's true. The problems with that month and all we discussed. In the sense, yeah, we have some this that is ordering that is brought about, and we can have some issues there. For that, we can even assume, okay, for this exercise, maybe we did one hot encoding. One second. Yeah. But the bigger problem that we have here is that the features are not in scale. So the moment I have price values as something like this and even area value as something like this, all the other features are dwarfed. The moment I take 42,000 minus 24,000, it is going to give me a very huge value. Then even if all these other features were same between 1 and, let's consider house 1 and house 5, if all their features were same, but just the house price itself was, largely different, then when I calculate how similar they are, it would have given me a very huge value. Now the problem, I think, as I think it was Selvaraj who mentioned, so the problem is that they are not in the same scale. So which is why we come to the idea of scaling. So the scaling the data and bringing all of them to a comparable scale is going to be very important to us. So once we do that, we can find similar points and we can go about it. So is that okay? Is that clear? Any doubts?
So scaling means
How would the
reducing
scaling be
the
defined?
value of the number.
Okay, I heard one question. Nishant, what was your question?
Sorry, I said how would the scaling be defined? Like I can see if we divide the area by 1,000 and price by 10,000, it will similarly bring everything to 1 to 5 scale.
Okay, yeah.
Uh,
So
but is that a right way to go, or should we even increase that or decrease that?
okay, so both of them are answers. So the first one, a scaling need not always be that we are just reducing the numbers. The idea of scaling is just to say that we are bringing all of them to a comparable value sort of range. Now we have uh, kitchen values, garden values taking 1 and 0, balconies as 102 and so on. But area is much higher. But this also, if I can somehow bring it around these values, it doesn't necessarily have to be the same values, but if I can bring it around those, then my calculations are now not going to be very distorted. And coming to Nishant's question, there are different methods with which we can scale the data set. So depending on which of them we use, the kind of values that we get are going to vary. We are going to look at a couple of them. In fact, I think yeah, the videos in this week also should have it. There was a video added on feature scaling that was done by the TA. We've just added it. There's another one by the prof also in the data pre-processing video where he discusses a couple of scaling methods. So depending on what you choose, you are going to get different set of values. So we'll see the examples in some time. But before that, can you think of some model which might, machine learning model, you've done your machine learning techniques course, can you think of some model that might very much be impacted if the data set is not scaled? One model will do, any one model. Can you think of it?
Regression.
Okay. Anybody else? One
The
model?
very basic model, the linear regression model itself will get impacted because of high contribution of area and price.
Okay, perfect. Anybody else has any model comes up to your head?
PCA also, no? PCA, principal component analysis.
Principal component analysis is affected by scaling. Sorry.
KNN is also affected by scaling because it will have impact in
Perfect.
the distance between 2 points.
Perfect. So KNN was one of the answers that I was looking for because we came up with the idea that we wanted to find similarity. We spoke about distances. And if I recollect, KNN is largely reliant on, rather it's mostly based on computing something like a Euclidean or Manhattan distance. And something like that definitely needs its features to be in scale. So yeah, so that was mostly what I wanted to discuss with this particular setup.
But in the MLT, we were taught that the kind of scaling that we use for the models is not always linear. I mean, it's not always multiplicational. It can be logarithmic or anything else as well.
Yeah, so the transformation, so those when we talk of them specifically as transformations, so we can always use different transformations on a particular feature. So there are different methods, and there is not always going to be a one shot method for a given scenario that says, okay, this will work. So the only part is that we do it consciously. So for one, there is something called as standard scaling. So you can take the mean and the standard deviation, and then you can transform the feature to come to that. Then there is min-max scaling, which puts the values between 0 and 1. Then you can do something called as max absolute scaling, which puts it between -1 and 1. So all these are different methods. There is not always going to be a one method that fits a given type of column. You are going to be trying out a couple of different things, and whichever works will end up being retained in your pipeline. Okay, we'll have a look at those. Okay, so far with this exercise, broadly we saw that you have categorical features, you might need to convert them. Why would you need to convert them? And then we saw that numerical features need to be scaled before we might want to use them. And we briefly sort of touched upon the idea that some models will be impacted by scaling and some models might not be. So the broader goal of this entire exercise is to say that you're going to be using a lot of different methods, and it is very important that you give a thought as to why I am using a particular method. And you understand, okay, this is what this method is going to do. I understand that these are its advantages, these are its disadvantages, but I am continuing to go with this. Or this is why I have gone for this alternate method. So whatever it might be, it is important that you communicate your ideas, because now it is very easy to get the code snippets. So documentation already gave you the code snippets, and now there are LLMs that will write entire code bases for you. So which is why this thought process is where you are going to be important. So this is why I have chosen to do XYZ. So whenever you are going to be presenting your work, that is what should be there. Okay. So up next, we'll briefly look at some parts. So let me just reshare. Okay, before that, any questions with what we have done so far? Has these things been clear? Okay, all right, great. Let me just reshare. Okay, so I hope my screen is now visible.
Yes, sir.
Is there anybody who is not familiar with this interface that I'm in? Anybody here who has not used this platform yet? Okay, all right. So this is Google Colab. So I'm going to be doing a bit of coding here. And in week 1, you have learned one library. What is it? Week 1 was largely content based on one particular
Pandas.
Yeah, so it was on pandas, and pandas is extremely important. So you learn it in week 1, but then that is something that is going to help you not just in the OPPs of this course or working with data sets, but also later on when you are going to either work or for your job interviews. Having a good control over pandas is very, very important. Okay, from week 2 onwards, we start with another library that is specifically for machine learning. Does anybody know what the library is called? Sorry?
Scikit-learn.
Yeah, it is Scikit-learn. So Scikit-learn is one of the primary libraries that we are going to be using throughout this course. And it has a lot of things that are very, very useful for us. From data pre-processing, cleaning, all the way until model building. Scikit-learn has everything we need. So I'm actually going to open the documentation for it. Okay. So with this, one of the things that I will say upfront with at the beginning of this course is that try to do all the coding yourself. So I understand that there will be so many tools now that can give you the code, but if you do not practice all these things yourself, it is going to be very difficult in the OPPs, and subsequently we've seen students struggle when it comes to coding for either any of these job placements or vivas or in presenting their projects and so on. So do make sure that you do all the coding by yourself, turn off any of these AI gen helps that will be there, and try and do all the coding yourself. Make use of the documentation. So the documentation is something that will be allowed to use even in your interviews and so on. And even with these documentations, the more you use it, the more you're going to get comfortable with it. Okay, so with that is going to be a common theme that is going to remain. With that, let's start. So this is the Scikit-learn documentation. So I'm going to show you that you don't really need to memorize anything, and we'll take out code snippets from this and try and do out our work. So let me actually just search loading dataset. So there are going to be three methods. We'll discuss a few of them, but let's see if this one has anything for us. Okay, we have data loading, utilities, real-world datasets, and so on. In fact, for these things, you can directly Google and come here also, but yeah. So we see a few of them here. So there is load iris, load diabetes, load digits, and so on. Just 1 second. Okay, there might be some background noise on my end. Please let me know if it gets too much. So here, these are some toy data sets that are present here. If we come to data loading utilities. So here, this says all the different data sets that are present in Scikit-learn itself that you can sort of take up. And it says there are toy data sets, real world data sets, generated data sets, and loading other data sets. We have these 4 things. Okay, so yes, we are going to be having PA sessions that is scheduled to begin from tomorrow. So we are going to have 2 sessions every week. Okay, until the break that is there for this month. That is going to be added in the calendar. So the first session will start tomorrow. So the sessions will be on Tuesdays and Fridays. I'll be adding it in the calendar. The timings will be there. It will be in the evening. Okay.
It will be the same calendar as this one, right?
Yeah, it will be in the same calendar. I'll update it. So yes. Coming back, yeah, if not, I'll also post it on Discourse. I hope all of you all are aware of Discourse. If not, you'll be able to access Discourse from your course portal. If by chance you find that the invite is not present in the calendar, you can check it up on Discourse. I'll make it a point to add it there. Okay. All right. So coming back, so loading a data set. Week 1 or week 2, I'll ask the TA to cover briefly from week 1. And you can always, whenever you have any doubts, you can anyways ask it to either us instructors or the TAs. That should not be an issue. Okay, so coming back, the first part is loading a data set. And in the case of Scikit-learn, for those of you who have already seen the lectures, you'll have seen 3 different types. Largely, we are going to talk about this thing about loading datasets, fetching datasets, and generating datasets. All these distinctions, it's not very important directly that you need to memorize it, but the code snippets will help. So we'll start with maybe the diabetes dataset or something. So we have something called as the diabetes dataset here. So all the datasets, all of them are discussed briefly, and it says I can click this to see specifically how to load them. So now I tell you to load one of the data sets. Maybe I specifically tell you one of these. There's iris, diabetes, and so on. Maybe you're asked to load the diabetes data set. So you can go to this load diabetes data set page. You can see the code snippet that is there below. So firstly, what does it say? I'm going to actually directly copy this. I'll put it in my collab. Okay, let me separate it out. In fact, first let's do a couple of imports. I'm going to import pandas as PD and import numpy as np. Okay. And I'm going to move these here. Now, Scikit-learn is the library. So from the Scikit-learn library, there are different modules. So the one that we have used here is called as the datasets module, and from that we have imported load diabetes. After that, I have called upon load diabetes here, and I've stored it in a variable called diabetes. Okay, and I've just run this set. Now, firstly, how do I know what this diabetes is? So there is this thing called as data frame. There are NumPy arrays. What is this diabetes like? How do I find out what it is? Any answers for this? I want to know what this is.
Type.
Perfect. So I can use type here. Okay. So when I use type, it says this is a bunch object. Now this is something you can go and read up on here also. So bunch objects is one thing that Scikit-learn gives us. Some of these data sets can be loaded as bunch objects, and they're going to have a couple of things to them. So this itself is going to contain both the features as well as the target and so on. So there are a few things you can read about it here. So understanding the type of the data that you have, or the way you have loaded it, tells you what are the different methods you can use on it. So now here they have done two things. Let me run this. So I'll just put it separately. So first diabetes.target, this and this. Okay, so can someone tell me what this shape is? What does the shape signify?
Rows cross columns.
442 samples and
how many
10
rows and how many columns?
Okay.
Dimensions.
Right. Yeah, so dimensions, number of rows, number of columns. So in this case, the first one is how many rows are present, and the second one is how many columns are present. Okay, now I'm going to load this slightly differently. Maybe let me just mark this as, I'll do this also in a separate cell. Okay, so I've done this. Let me see if I can do. Yeah, so can you all read what is, are you able to read whatever is there here? Zoom in a bit, regardless. This is better, right? Okay. So you can see some things written here. Does anybody have any idea how I can fix this?
Print.
Okay, perfect. So I can use print, and now it should become pretty. So now this gives me a description of the data set. It says there are 10 baseline variables, so and so and so. There are so many instances, and it gives me a brief description of what all these different features are. So you can always see more of the information on this. Okay, so that was what we had. So we saw these are nothing but, it says show me 3 values from the target variable. In fact, some of the functions like type are going to be very, very helpful to you, because that is how you are going to deal with bugs. So now let me do this. Now we're going to see that it's a numpy.nd array. So I think okay, in the chat we have .head and .info. Now that's actually something I can show here. So let me do this. Diabetes.data. So diabetes.data, this is the features actually. And now this guy also, I'm going to put the type, and it's a numpy nd array. And here I'm going to do diabetes.data.head. Okay. Now do you see an error? It says numpy.nd array object has no attribute head. So this brings upon the sort of idea for us that depending on what data type we have, there are going to be some methods that we can use and some that we cannot. So methods like head and info are very common, but we cannot use it with everything. Now if I do it for the bunch object, it does not even tell me that it is you know that it's because it's a bunch, and I cannot use it here and so on. Here at least it was
So if we
clearer.
import the data as the Panda
Yeah, I'll
data
come
set.
to that. So yeah, that was the idea. So the question is, where can I use head firstly? For what type of data set can I use head?
Data frame.
Data frame.
Data frame.
Yeah, so now if I want it as a data frame, now we saw that it was there as bunch, and when I took it out separately, so what the bunch object had two things. It was called diabetes, and I could do data and I could do target. So it had these two things. And when I saw the types of these, they were nothing but numpy ND arrays. But I can make my life easier, or rather, Scikit-learn has made my life easier in making it easier for us to take out objects as data frames. So I can just
As
write
data
it here and
frame
then go
true.
here. Yeah. Let me do it. So I'm going to call it as diabetes data, and it is load diabetes. Now there's actually a couple of parameters I can give. So one is called as return xy, which gives me the data and the target that was there separately, but instead it's going to be called as x and y. The other is to bring it out as a data frame. So, and that is given by as frame. You can see it here, and I'm going to give it as true. Now, I've been doing this for quite a while, so some of these things are there in memory for me. But to show you that it is not at all difficult to get it from the documentation, all you need to do is you need to come here, you come to the parameters, and the first thing it says is return xy. The second thing is it says it is as frame. Now the third one, scaled, we don't use it that often because it's better we can observe the data first and then choose whether we want to do this. But as frame and return xy are very convenient for us. The first one says that I want the data set as a pandas data frame. So this is where I told you that pandas is very important. It's going to be important throughout your sort of career where you use this classical ML and work with data sets. Because it is a pandas data frame objects, and all your pandas methods is going to be applicable on it. So this has given me the data set as a data frame. And return xy says I want the data separately as data and target. So let's just do that part now. So I come back here, I'm going to load this. I've given as frame is true. I've called it diabetes data. Once again, I'm going to put the type here. And we have diabetes data type now as, okay, it is there as Scikit-learn utils.bunch as frame. Okay. Yeah, so, but this should actually be a data frame. Let me see the head method. Okay, why is it showing like this?
Could you write data diabetes data dot head?
Yeah, that is going to work. I mean, if it comes as a numpy ND array, but this is supposed to come as a pandas data frame.
Actually, the data set which we are loading is this is a bunch.
Yeah, it is a bunch. So
So,
I need to do it as.
so we have to indexing like data
Yeah,
so that we
if I
can.
go to data.data, it will give me a data frame, but all right. So I'll have to add return xy to it. So then I'll get both of them as data frames. So if I add return xy here, and if I change this to comma features, yes, okay, write it as data comma target. Now let me get the type of data. Okay, so now it's a data frame. Let me call this as diabetes data. So what I've done here is I've used the load diabetes. I've mentioned as frame equal to true, and I've done return xy also equal to true. So now with this, I have two things. The first part is x, my features. The second part is y, my target. Now I can write diabetes data here. Okay, I realize the problem. It's probably from using the same variable names. Okay, now we are back to this. So now I can do x dot head, and now you can see that particular data set has these many features. It had 10 in total. So the last one was the target. So 10 features otherwise, and then a target. So these are your features, and data.head simply gives you the first few rows of the data frame. So is that okay? And now there was one more method called info. So let me run that as well. So info method tells you, it gives you a sort of a snapshot of the different columns and how many values are not null. But here you should note that this only accounts for null values where it is already present as null, and not if if it is entered as unknown or some question mark or with some other variable. The info method does not capture that. It also tells us
So
the data type.
y is also a data frame? Y is also a data frame?
Y is a series. So if I were to, it is also a pandas object, but it is called as a series because
And
it's
y is a series and okay.
yeah.
Right.
Will the info method also work on diabetes directly instead of x.info? Can we go for diabetes.info
Yeah,
bracket?
so it depends on the type of object. So actually, let me try for another data set. 1 second. Let's load the wine data set. Again, a bunch object. This must be a new object. Fine. Let me go for the same thing. So you wanted to use it on this. You wanted to use which method on the diabetes data?
Diabetes.info bracket.
Okay, so that will not be happening. So here, if I let me, because it is under diabetes.data, and that is a numpy ND array. So numpy ND array does not have info in it. So info method is for a pandas data frame. So whatever I've named as X here, so I've done load diabetes as frame and then return both X, Y. So because this is a pandas data frame, this has some methods. Let's, for one.
But after converting into a frame, data frame,
Yeah.
can we call out for diabetes.info with brackets so that it gives X and Y together?
Yeah, so you can combine the two of them. So it used to be the case that you can actually, once you load it as a frame, you could get it as a single variable. I am not sure when the update, so to speak, has happened. So previously it was wine data. Okay. So let me actually just take the, I don't know if I can call this. Now, if I want, I have to actually get both of them in the same one. So I can either just to add them, or I can, now here I'll have to go to something called as wine data for it first. And if I do this, now this wine object. Yeah, so now this is there as a data frame, and now for this guy you can use it. So this is also once again only the features. It does not have the target variable. So now, however, if I would want it as a target variable, yeah, you'll have to combine the two of them. So I'll recheck and I'll update that in the next session also once, because it was possible to load the entire thing as a data frame without really splitting the X and Y. I'm not sure exactly when this update happened.
So in that last update, what happens if we do wine.info with brackets?
Sorry? Yeah, so in this one we can use wine.info. If it is a pandas data frame, you can do it. It's just what method is allowed where, that is the only thing. So if I use it here, it shows this whole thing. What I was trying to do is I was trying to get both the data and target in the same sort of this one, within the same thing. Okay, anyways, let's have a look at it later in the next session. So this is loading a data set. So this particular data set is one that is already present in your Scikit-learn. So you can get larger data sets with using the fetch methods that are there here. If I go back here, there are real world data sets. So you can see the 20 news group data set. What we saw first was all this load wine, load diabetes. But these, if you see, are fetch 20 news group, fetch Olivetti faces, fetch whatever KDD cup, and so on. So these are larger data sets and they work slightly differently. They are not already there with Scikit-learn, so this might need to download it. And finally, there's also something called as generators, in which we can choose to generate our own custom data if we want to see something. Okay, so we'll actually be exploring data a lot more in the next session. But briefly put, there are many methods you can use. Like some of the useful ones, so to say, is, let me do load one. So if I put a question mark first, it opens up a thing on the side, and this is effectively the documentation itself. So whatever we saw here as load diabetes, so whatever we saw as load diabetes here, so if I put a question mark within the collab environment, so this is especially useful when you are doing your OPPs. In your proctored exams, you are not allowed to go to the documentation directly, but you can open it within the collab itself. Okay, so this is one thing. Another way you can do it is to use the help functions directly. So that time it prints it here. So this is one more option. Okay, and there's one more I'd like to present. So I think it should come with this. So what I've used here is dir, and what it does is all the things PD stands for pandas here. If you recollect, we imported pandas as PD. So which is why when I do dir PD, it tells me all the methods that are there inside this. So there's a few things we actually need to find specifically for data frame. If you come here, you can see, yeah, there is data frame. So let me do PD dot data frame. If I'm not wrong, we should show the methods of data frame. Okay. So now here, I think you have one of you had a question of what happens, where can I use info, what will I get, and so on. So now whatever you see here are all the methods you can use for data frame type objects. So we made use of info, right? So we should find info somewhere here. Yeah, so can you see info here? Info is there here. We also made use of head. Where is, yeah, head is here. So this also tells you there are so many more methods. Let's see if this, yeah, there is not NA and not null. Let me see if I can, yeah, there should be describe and all that. Yeah, there is describe here. Let me show describe. So what did we call this data set? We called it Wine. So I'll do a wine.data.describe. Okay, so this is already as a data. Right. Okay, so when I do wine.describe, what this gives is mean, standard deviation, minimum value, different quantiles, and the count, and so on. So in the next week, we'll be seeing a lot more with this. We'll be doing a lot more coding and seeing these in detail. But what I want to show is for the question that, what happens when I use this method, where can I use it? You can simply check. So here I've used dir to see what are the different methods I can use for a data frame. And we've basically got this, that. So now we can also do it for NumPy. So if I come to NumPy, these are the methods that are there in NumPy. And I think this should also have something like an ND array. If it has an ND array, then that will again tell us whether or not we can use some of the things. Okay, there is an ND array. Let me just try that as well. Okay, so here, if you see in I, there is only imag item set. There is no info, right? So this says that if the data type is ND array, then I cannot use info here. Likewise, there is no describe also. Even that is not present. There is no method head, which is why we were getting that error. So what we did so far is we loaded a data set. We saw its type, so it could have been a bunch, it could have been ND array, it could have been a data frame. And depending on what it was, we could end up using different methods. Exactly what methods we can use, we saw it inside the dir function. So if we want pandas, we could do pandas, we took the alias as PD in the beginning. So we did PD dot whatever data frame we put. Then we saw all the methods applicable there. So with this, the part about debugging should be very easy. So now, whatever exercise we did today, at least looking at the documentation and loading a data set. You look at the documentation, you load a data set either as a data frame or as an ND array. How many of y'all are confident about being able to recreate just this much? Can I get a show of hands? That if someone were to ask you to open a collab and tell you, just load a data set using only the documentation, I can do it. Okay. So we have 8 people. So there's total of 30. So remaining, okay, can I get a show of hands of people? I've lowered everybody's. Can I get a show of hands of people who cannot do it? How many people here are not confident about loading a data set using just the documentation? Okay. So what part of this was not clear?
Sir, how to upload that file, sir?
Okay, are you talking about the diabetes and wine dataset and all that we saw so far?
Any file. I am.
Okay, yeah. So I was specifically
Not audible. Sir, not audible.
asking for.
Could you repeat?
Simple. So you're saying,
Can you repeat,
sorry, am
sir?
I audible now? Yeah.
Now only it is, sir. You are audible.
Yeah. Okay. Sorry about that. So if it is Scikit-learn datasets, you can simply do from Scikit-learn.datasets import load diabetes. So for any dataset that is already there in Scikit-learn, this is the simple, straightforward, easy method. So now when it comes to external datasets, what you will need to do is you can click this button here. This looks like a folder. There is a file upload button. I'll have to check if I have any datasets that I can load. Let me see. I'll try and add a small dataset.
So do we need to mount the drive every time?
No, you don't. See, mounting the drive is different. So this is This is Mount Drive. So if you do that, it connects to your Google Drive account. Now, that is only needed if you have some data sets there and you want to directly use it. Okay, something like that.
And so, if I make changes in that data set, will it be there in my drive?
You can choose to do that as well. So you can choose to read files from your Google Drive and make updates on them here. You can do that.
Okay, sir.
So that is all up to you. But if you're going to use Mount Drive and if you're going to control there, you're going to have to give some security keys and all that. It's not too complicated, but it's not. It's like you need to do the initial setup for it. Okay, here I've actually uploaded one file, which I think should have actually come as a practice assignment. I'm not sure if it has been released. But here I'm trying to, I've added a CSV file. So using this button, it opens up a window, then you just click the file locally. And you see this circle, right? This is to indicate
So,
whether...
sir, this is the instance memory. I mean, if I close the session, then it will be gone.
Correct. So this is temporary. So whatever we add using this way, it is temporary. And once it's loaded, you'll even get sort of like you'll get a notification when you upload this here saying that these files can be lost. So if you were to update this now, for example, let me read this. So to read the file, what I can do is I'm going to call data is equal to pd.read CSV, and I'm going to pass this link here. So there is a copy path, and then put it here. Okay, so now my data is going to have this particular CSV file. We'll do a type of data, and it is a data frame. And now I can do data.head to see the first few values. And as you can see, this is how my data set actually looks like. Okay. So this is adding an external data set. Is this clear, Prakash?
Sir, okay, but header only must come. Why it is coming like that? All the things. Header file. Header means data.
Head does not mean header. Head means the first few things. So I can put tail here, and it will show me the last 5 rows.
Okay.
Okay.
Head means the first 3, yeah, first 4.
Head is first 5. So I can put 10 here, and now it will show me 10 rows.
First 10.
Yes. So by default, it will show the first 5. Okay.
Okay. It will be in the data frame, sir. Rows and columns.
Yeah. These are the ones from the data frame. Okay.
Okay. Sir, should we do like that in the OPP?
In the OPP, you are going to be correct. In the OPP, you will be given a data set. So you need to upload that data set and then read it like this using pd.read CSV. So before your OPP, you are going to get a lot more details regarding.
Okay. Thanks.
Okay. Loading from drive, I actually will not. I cannot show it here because I don't want to connect my drive to this account. So what you can do is you simply need to click on Mount Drive. It will ask for permission. So you say connect to Google Drive, then it will get permission, and everything that is there in your drive will be listed here. So given that I have like some content related to different courses and things that I cannot necessarily present here, so I cannot connect it. But you do that, and then you can read the files and all that. It might sometimes ask you for authentication to edit things. Like for example, a lot of like big Google Sheets and all can directly be connected here and can be processed using Google Colab. You can then process it even as pandas and then save it back also. All those things are possible. So anyway, those are things that you can explore.
So one thing, could you please show, I mean, how to load data from URL?
Yeah, loading data from URLs also is very similar. So as a matter of fact, what I have here, right? So if I simply put a URL here, it will load actually. It's as simple as that.
But the URL, how can I get that URL, sir?
So URL is something.
Kaggle.
No, URL is something someone would have given to you. So like for example, let me open. I'll actually show one data set that is there. Can't directly open without, it's from some OPP papers.
Sir, can we see the entire data here?
Yes. So entire data, I'll tell you the problem why we why we don't generally get to see entire data. Just 1 second. I'm just trying to show the URL part once. Okay, so in the meantime, let me show this part also. So I've just loaded this data set, right? So I think I called it as, okay, I called it as data itself. So yeah, so if you see what does this indicate?
4 rows and 4,000.
4,800 rows, correct. So now
Yeah.
if I do data.head, let me do say 50.
Inside.
And now I'll even zoom out. So this is back at 100 resolution. So there is already a scroll bar here. Now if 50 rows itself is like this. So the moment I load all 4,800, it will be present, it will be there as a scrollable bar, but then it's not very easy to work with, right? So anyway, all the rows are loaded. They are loaded at once. So head is just showing you the first few rows. That is all there is to it. Does that answer your question?
Will it show all the rows, 4,803 rows?
Yeah, so you can choose to go even higher. Like for example, if I were to simply put data here, it will actually show these things, but then it will go as ... here. Do you see here?
Oh.
After 4, it goes to that. Now this and all, you can choose to manually increase the number of rows. There is something called as a set option that you can do in pandas, such that both your columns and rows are not. For example, even the columns also. In this, I've probably reduced the columns. Otherwise, even in the columns, you'll get a ... if there are too many columns. Okay. So yeah, you can slice a data set that is anyway given. So here I was just showing how to, if you want all of them, how will it look like. So this is the slicing part. So this is all rows, all columns. Okay, did you mean that I can use this to show all of them? So here also it will end up being the same thing actually. So the only thing to do is to use something called as set options and increment it. And here if I want, I can say you give me up to 10 rows, but show me only the first 3 columns. Okay. So I ended up putting 4. So the first 4 columns. So it shows me column numbers 0, 1, 2 and 3 and up to 10 rows. So it shows 0 until 9. Okay, so this is something called as the iloc method. All this will actually see more while coding. Okay, with that there was one URL thing. Let me open that. Okay, is this visible? Is my screen visible? Yeah, right?
Yes, sir.
So this is a CSV file that is there in a URL. So now what I'm going to do is I'm going to pass this here. So here I can do.
And that address is a URL of a drive, right, sir?
Yeah. So this is a this is a file that is stored in a Google Drive.
Okay, sir.
Okay. So here there is some issue with the dataset thing. So this is one problem actually you will have with URLs. So maybe I do that.
So the permission can be.
Yeah.
Yeah. So. Yes, please.
So, sir, go ahead.
Yeah, is there a question?
So I was asking if the permission is not given for that drive, the data set.
This actually it also has the part of this whole thing having this whole URL. It will not entirely take it. I actually have to update it a little. I will have to do some extra coding. Let me show that. So in general, like if you have some directly usable URLs, you can do that. So here I have to do some extra steps for it.
Actually, sir, I was asking the loading data from URL is the data of Kaggle data sets.
Okay, yeah, even Kaggle datasets also you can do it, but with Kaggle datasets I would recommend that you do it in Kaggle itself. So you open a notebook in Kaggle, it is the same Jupyter notebook interface, and you just continue using it there.
So we are not allowed to load that data in this.
So that's the thing. You can do it. See, the problem with making use of these URL ones is that, so if there are these sort of if it doesn't load the entire thing, right?
Yes.
This I don't know if it was too much for its chunk, but if the size is too large, sometimes it doesn't load the entire thing.
Okay,
Okay.
sir.
So here, so I can show the code snippet for it. So that same link, you kind of have to process it a little and then run it. But the problem is if you have 10,000 rows, like for example, even with uploading here, right? So while it is in the process of being uploaded, if you then itself, if you run this data.read CSV, then it'll end up being the case that sometimes only partially the data set is read. So you'll have to wait for some time before you do it. The same thing sometimes tends to happen with these URLs also. It can be the case that the entire data set is not read in one go. So with Kaggle 1, there will be another session in which I'm going to work on a Kaggle data set. So at that time, if you still have any queries, we can answer those then.
Right, sir. Right, sir. Yeah. Thank you.
Sir?
Yeah.
It is a pre-processing the data. How to remove the duplicates and outliers and how to do that analysis?
Okay, yeah. So those are all part of data pre-processing and cleaning. So in the case of data cleaning, we handle missing values, we handle duplicates, we convert features if they're not in a usable format, and we also have to deal with outliers. So all these things are there. So I think missing values and outliers are added as new lectures in the videos. So it might be a brief introduction, but it tells you of some of the methods. Do look at it. Anyway, I'll be covering it in the next session as well. So yeah, with that, I'm actually going to conclude today's session. Pandas, I have not taken any session on pandas, but I think there. Have you gone through the videos on the portal and have you attended the previous live session? Okay, if you have not done that, you can have a look at it. The previous two live sessions were on pandas by one of the other instructors. There are also previous live sessions done on pandas and videos, so you can have a look at it. If not, okay, I did not see the query. Okay, with live sessions we have on Monday and Thursday. Monday and Thursday, 8 to 10 is the live session, and yes, the project live session is from 7 to 8 p.m. So MLP project in general is not recommended to take with the course. But yeah, if you do end up doing it with the course also, it is fine, but it might be a bit challenging. The live sessions don't clash, but we cannot move it to some other time because it can crash with other courses and so on. So yeah, Monday to Thursday, instructor live sessions 8 to 10. TA live sessions will be on Tuesday and Friday. On one of the days it is 8 to 10, on another it is 6 to 8. I'll update it in the calendar shortly. Okay. Yeah. So with that, so today what we did is we saw a data set and we saw motivation. With the general idea that you all have to take is that you don't first learn the methods and then think about okay, I'm just going to apply them to a data set, but rather you try and understand your data set first. What does my data need should be your question. So when you have a look, when you saw the data, you saw okay, there are text related things. My model cannot deal with them. I need it to be numbers, so I'm going to convert it. So the next thing is, how do I convert my categorical variables? So I can convert them to numbers. Either one method was ordinal encoding, another method was one-hot encoding. Then what were the pros and cons of that? So that way we went about things. And actually the thing is, there are more encoding methods as well. But this should be your approach towards anything. There are going to be so many new things, but your approach should be, why am I doing something? And then what are my pros and cons for the same? Okay, so if you follow this approach, it makes the work that you do better. Now, in this video, we primarily discuss things around those areas, a bit about encoding, a bit about scaling, and we just saw briefly about loading the data set and what methods are applicable where. Now, the subsequent session will entirely be coding. We'll be doing it entirely on Colab. We are going to be trying out different pre-processing techniques. We're going to be trying out different cleaning techniques, loading the data sets and so on. I urge all of you all also to practice, because you will be giving me the code and I will be doing it live. And if we have any mistakes, we are going to correct it together. Okay. So do practice pandas and SQL. So if there are any other queries that based on today's session, I can answer them now. If not, we can. I'll see you all in the next session. Okay. Yeah. Any other queries? Okay. All right. Thanks everyone for joining. Then I'll be ending
Thank you,
this
sir.
room and closing the
Thank you.
session now. I'll see you all next time.
Thank you, sir.
Thank you, sir.
All right. Okay. Thank